Inventories serve players as great managing systems for many games, helping players store potions, ruins, and precious loot. Today we're looking at how these work and how you build one yourself in Unity. We have Cameron showing you the item class, Anthony with the inventory management, and Kale with the player management and how all these classes come together. Let's do it. To start off our inventory, we need an item class. So if you right click, go to create and C# creates this, and I shall call it item. Double click and it opens up Visual Studio. Now we don't need any of the default code. But I want to make a few variables to keep track of our items, such as item ID, item count, item name, stack size for our quantities, and just to pull the library, item descending, and item flavor. Now we also need to create a method for our when an item is made. Oops. And so item name equals name. Yes. Now you might have noticed that we made the item count variable static so it doesn't change. And it might be strange considering we want to count it, but if we keep it static and not changing for each individual one, then we have a clear number for every single item counted. So every 1, 2, 3, 4, 5, they're all individual, and you can find them simply from that number when they're created. File and save. And that's the item class.
Now that we have our item class script, we're going to need a manager to add in items. First, let's right click and create an empty game object. We'll call this Game Manager. Now we're going to create and attach a script called Item Manager. Now we're going to double click Item Manager to start scripting. Next, let's create a private list of class item. Item being this, we'll call it item list equals new list, class item again, and brackets. Next, we're going to need an array for our sprites that we're going to use for these items. We'll call this public sprite. This is just a Unity engine class, as you can see there. and we'll call it sprite list. Next, we're going to go back to Unity Editor, and we need to add in our actual sprites into our project. We don't have any sprites here, but I do have sprites over here, so we're going to just drag them into our project. Go back to our game manager. You may notice now that we have a sprite list size 0, this sprite list. Since it's public, it means that it appears in the inspector, and it means that we can change the size here to 3. Next, we're going to add these one by one into the inspector. So blue dice first, Naruto Runner second, and Jamie third. Now time to go back into our code editor, and we're going to start adding them inside our script. So we're going to do item list dot add new item. Here we can put whatever we want. It doesn't really matter, but to be descriptive, we're going to call it based on whatever we have here. So it doesn't have to be the same case. It's not case sensitive. So we'll just type in blue dice. After clicking space, you can see that it shows us which properties the item needs. So these properties, name, stack size, and sprite. So we can just go stack size of 64, and the sprite, we're going to use this sprite. So we're going to do sprite list 0. The 0 element 0 over here. Yep. Now we're going to repeat for the next items. So this one, Naruto Runner, stack size 64, sprite list 1, item list dot add new item Jamie 64 sprite list 2. Now we don't need the update method, but we do need a getter method to get these items. Let's create the method. We'll call it public item get item by ID, and we're going to need a parameter here. So we're going to put int ID, and we're going to do a for each loop. I'll describe it as I go. So for each item class item in item list being the one that we made over here, if item dot item ID equals to ID, return the item. If not, return null. And that gets rid of the error that we saw before. And now we've got our item manager.
Now that we have both an item class and an item manager class, we will create the class that will actually contain the player's inventory. We'll start by creating a new script called player inventory. Let's open that. Let's get rid of all this, since we will not need it. The first variable we'll need to create will be a global variable for the inventory size. I'm going to set it to 20, since that's an appropriate value. You'll also notice that it's constant, as our inventory will not have a changing inventory size. If you do wish to have a changing inventory size, you'll have to modify some of the methods within this class to account for it, as these methods are going to assume that the inventory size doesn't change over the course of the game. Next, we'll have an item array, which will be the player's inventory and will store the player's items. Make it type item, and then the inventory. Now we'll initialize it. I'm also going to create another array. This time it will be an int, and it will store the amount of each item in each slot. Note that these arrays will be the same size, since we'll keep track of the number of items in each slot. I've set these arrays up as static so that everything in this class can be accessed without a reference. Let's add some methods so that we can interact with the inventory. Firstly, we'll want to add some items to the inventory, so let's set up a method that can do that now. This method will need an item, and the amount of said item that we want to add to the player's inventory, which I've defined here in the parameters. It's important to think now about how we want our inventory to work. When we add an item to this inventory, we're going to want to look for an item, a slot that already has this item in it. And we'll check if it's at the maximum stack size or not. And if it's not, then we want to add the items to that stack first. So first, we're going to want to iterate over the inventory, looking for the first item slot that is not empty. So I'm using a for loop to do this, and I'm iterating over the inventory size. And I'll use this this I variable to iterate over the inventory. First, I'm going to perform a check on the inventory and see if the current slot we're up to is empty or not. So if this is true, then we have found an item in this inventory slot, and now we're going to want to do a check on this slot to check if it's the same as the item we're working with. And we'll also add an extra check in to see if it's less than the stack size. Because if it's over the stack size or equal to, we will not be adding items to the stack. So now we're going to want to perform a check to see if the amount of items we're trying to add plus the amount of items currently in the slot is greater than the stack size. So in this scenario where this is true, we're going to want to adjust count, make this inventory slot a full stack, and continue. Let's do that now. Now if we are under the stack size, then we're going to be adding the remaining items to this stack, and then we'll be finished with this method. So we want to add a return at the end of this section. And then we return. So that's the section on adding items to items already in the inventory. Next we're going to be, if this isn't the case, and either we've exhausted all slots, or there are no slots of this item, then we're going to want to start looking for empty slots. So we're going to exit this for loop, and we'll create another one. And again, we're going to iterate over the entire inventory. So this time we're going to be ensuring that whatever we're working with is equal to null, or that the item slot is empty. Let's do that check. And now, if count is greater than the item stack size, then we have to do the same thing that we did above, where we adjust the count and continue. So at this stage, we're going to want to check to see if the amount of items we're adding is greater than one stack. Because if it's greater than, then we need to adjust count and then continue. Now, if the slot is completely empty and our count is less than one stack, then we can place the items in this slot and return them from the function. Now it's important to consider that if we get through both of these loops all the way down to the bottom here, then we have a case where we've filled all slots that already have the item, and we've filled all empty slots with items, and have leftover items. So we have to return the amount of It's important to realize that if we reach the bottom here without returning, then we have the case of we've filled all current slots with items, including of items that already existed and empty slots. So we're going to use a return here to indicate to whatever called this method that we have items left over that could not be added to the inventory. So I'm going to return count. Count, of course, being the remaining items, since we modify it each time we do anything to it. That concludes this function. I also like to add a small method that enables readability. If a function were to use this method, it would increase readability slightly. It's also a very common action to perform, to only add one item. Next, we're going to want to remove items from inventory, so let's add the functionality for that now. Similarly to the above, we're going to want to give it an item and the amount of items we want to remove from the inventory. Similarly to the add items method, we also need to iterate over the entire inventory looking for items. This method becomes a little bit simpler because we don't need to care about empty slots, as there's no items to remove from an empty slot. Let's set up iterating over the inventory again. Again, we have to perform a check to make sure that we are working with a slot that is not empty. And now we make sure that the inventory slot we are working with has the item we're trying to work with in it. So now we need to check if the amount of items we're trying to move is more or less than the amount of items in this current slot. If we're trying to remove more than what's in this slot, then we'll have to empty this slot and then continue. So we're going to check if count is greater than the amount of items in this slot, and then we'll adjust count, and then we'll set that item slot to be empty. Now, if count is less than the amount of, or equal to the amount of items in this slot, then we can just remove the items from the slot and we will be finished. Now, again, it's important to consider that if we get to the bottom of this for loop without returning, then something's gone wrong. Likely that we've tried to remove more items from the inventory than are actually in the inventory. So because we're modifying count as we go, we can just return the count. This provides enough information to whatever called this method to say that this was the amount of items that could not be removed from the inventory. And again, I like to provide a method that increases readability if you use it. Now, it's also important that we can see what items are in each slot and the amounts. So let's make getter methods for those. That's one for an item, and let's add one for the amounts. These getters are very easy to make since these indexes, or the integers that we want to return, are just straight from the data structures. It's important we have these because, as you'll see up above, we created these as private. This is critical so that these aren't modified via external classes, but you still access the elements inside them via getter methods. The last method we'll want to add to this class is a method that can swap two items in the inventory. This is a method that tends to get a lot of use. It's very easy to understand since it's based off a simple swap pattern using three variables. The two that we hand in, and a temporary variable which we'll create. And with that, we've created an inventory that we can interact with through code. During the recording, I made one small error here. This needs to be I. We're not setting an entire array to an int. Also, further down, during the recording of this tutorial, I made a small error here, which needs to have a reference to the specific slot of the array, since we cannot set an entire array to an int. And further down here, I set this return type, which should be an item instead of an integer. Don't forget to save the project. During the recording of this tutorial, I made a small error here, which needs to have a reference to the specific slot of the array, since we cannot set an entire array to an int. And further down here, I set this return type, which should be an item instead of an integer. Don't forget to save the project. This is a small game I've created to demonstrate the features of the scripts we've just made. As you can see, I play as a little red square. I can currently press E to open an inventory, of which is currently empty. I can also select these empty slots, but it doesn't do anything for the moment. I'll go pick up some of these items. As you can see, they've made their way into my inventory. They've also stacked. Let's go pick up the rest of the items. These have also made their way into my inventory, and they have also stacked. Now that these items are in my inventory, I can select and move these items as I please. This makes use of the swap method we created. This small demo only scratches the surface of what you can do with the simple inventory setup we've created here, but it proves that it's effective and intuitive. In reflection, this code is designed to reduce the overhead of introducing new items, and the underlying data structures accommodate this intention very well. However, it lacks some methods that could prove to be very useful, such as controls to provide more control over the spread of items in the inventory. Some examples include being able to split a stack, take one from an item slot, and distribute items evenly over empty slots. Overall, while this code can prove to be very useful for small and simple games, it will likely fall short of the requirements of more advanced games in its current state. For these games, it provides an adequate framework from which more development can be made.